Hi everyone, and welcome back again to my channel. Today we're going to look at basic electronic symbols. We're also going to look at how to draw good schematic diagrams. All right, stay tuned and let's go right into it. So in this tutorial, as I good electronic schematic diagrams, and we promise to look at some of those today. So let's start by looking at the some basic symbols. All right, so in our world, in our field, we deal with transistors, resistors, inductors, capacitors, and so on and so forth. We also deal with ICs, integrated circuits. So let's just look at some of them. Let's start from the basic. Right, so the first symbol we're gonna draw is gonna be just plain wires, right? Plain wires or just connectors. Let's just draw plain wires or connectors. All right, so this will just be a wire, if you will, and then you can let's say we have wires crossing. Formerly, people would draw it this way to show they were not connected. But the better way to draw it is just if they're not connected, they simply go across each other. And when they are connected, then you put a bubble to show they're connected. All right. So this is it. This is the first thing. Connectors or wires that we use for connections. Just straight up lines. We're gonna look at this again when we look at how to draw circuit diagrams. So let's proceed by drawing other components. Let's draw a resistor. A resistor is a straight line with some kind of zigzag symbol around it. This is your resistor. So one thing to note about resistors is if you start by going up, let's say this is the A and that end is the B. If you go up, when you're going to end, you have to end from down. That's the good way to draw it. So one is going up, the other is coming. So both of them are actually going up or going down, if you will. So let's do another one. So if this is A, that is B, you might decide to go down first. But what that means is this is going to come down as well, right? So it's going to go this way. All right. So notice that these are good ways to draw resistors. You should never draw a resistor like this. So we're going to do A. I'm going to do B here. You should never draw resistors starting with up and ending with down. This is a bad way to draw a resistor. Likewise, you should never draw a resistor starting with down and ending with up. No. Also, why don't we use a different color to show bad and good? Okay, let's use red to show bad way of doing things. So bad. All right, let's use green. Now remembering my primary school teachers. Okay, I'm not gonna mention anyone's name since I didn't get clearance to say their names online, but yeah. How about a transistor? So let's do transistor. We are transistor fans, right? We did transistors as switches and so on and so forth. So this is a transistor. But as you can tell right away, it is not neither an NPN nor a PNP transistor, just a transistor, right? So let's make two transistors. Then I also show you a bad way of drawing a transistor, okay? So these are two transistors. So let's make one of them NPN and the other PNP. So let's make this one NPN and make this PNP. So to do that, we got to put an arrow going out. We're going to put an arrow going in. So PNP, NPN. Basically, you know, this is the base for each. This is collector for each. This is emitter for each. All right. Remember how we showed in a previous video how to tell the NPN from the PNP such that the arrows are pointing down for both. Why don't we make it? Let's do joint transistor. The arrow is pointing down. You're gonna know why I wanted to make it giant soon. And then remember what you do to the right, you do to the left. Those are on the portion that faces the bottom of your screen. Now to the left of each. So if this is the center line, so I assume this is also center line, right? I don't know how you write your center. If you write it this way, it's fine. It doesn't matter. But I'm gonna write the first one line. Left of the center line, right of the center line. On the left, okay, I'm gonna circle the left. Remember, you can pause this video anytime. On the left, just put an arrow. Let's use a different color. Let's use this light blue. On the left side, just put a stroke down on the left. Yep. Now let's use highlighter. Let's do something different. So look at these two. Which of them looks like an N? This one looks like an N, right? This one looks like an inverted N. I will just use this to mean does not look like an N, right? Okay, let's not do that. Let's just show what it looks like. It looks like an inverted N, right? So let's go to primary school and we're gonna say bad way of writing N, and we're gonna say good way of writing N. So whichever looks like an N is your NPN transistor. Okay, easy. That's your transistor. So let's look at the diode. So we looked at the resistors and transistors. Let's look at the diode. So a diode, let's use a black. The diode has two terminals. It's a PN junction, right? So the terminals, there are two terminals, A and B, right? So we know they are just two terminals or pins. One of them is anode, the other is cathode. Now let's just show how to tell them apart. Okay, you can say A is for anode and B is for cathode, but I'll show you a different way to tell. Okay, so cathode sounds like K, cathode, right? Cathode. So look at this. Let's redraw this diode. Let's draw it backwards. Let's draw it this way. It's still the same. So just that here our A is now here and our B is over there. All right. So remember I said it sounds like for cathode. Let's use a highlighter. Let's use a highlighter right now. So let's find K. Let's find K. Remember cathode, K for cathode. The junction that looks like an K, the letter K, is your cathode. Okay. So since they are just two terminals, once you find one, the other one is if I find the cathode, the other terminal is the anode. So it's easy, right? So anode goes over here, anode, and cathode here. Okay. So whatever looks like K, so this is like an inverted K, so this is your cathode. All right. You can pause the video, you can go back and rewatch it. Okay. So let's look at capacitors. There are different types of capacitors. Okay, we're gonna look at a few of them. We might not look at everything today, but as time permits, we'll look at what we can look at, right? So one of the capacitor symbols, just the basic. Let's just do the basic symbols, and then we can add as much as we want. So capacitors are just two parallel plates. Two parallel plates. Make some capacitors at home. If we have time, we can make some in the channel, but just make some at home. Just take two parallel plates. Take an aluminum foil and put an insulator. Let's use a gray color. So put an insulator to separate it from another one. Let's use a different color to draw the second plate, aluminum plate. Make sure they're about the same size. So this is the B side. That's the A side. So you have the insulator in between, separating plate. Let's just call it material. Yeah, then attach wires to it. Attach wires to A and B, and that is your capacitor. So you can roll it up. Then just have the terminals coming out from there. Then you have your capacitor. Okay. Right. So that's your capacitor. So this is the basic one. This is non-polarized. You have the polarized capacitor. All right. And some people would draw this in a slightly different way. Right. So one will be this way, and one will be filled inside. All right. So there are more capacitor symbols we can draw, and also more transistor symbols and more diode symbols. We're gonna go back and add a little bit more, but let's just do some capacitors more. Okay. Let's do variable capacitor. So capacitor symbol with an arrow across it represents a variable capacitor. You can also have a ganged capacitor. A ganged capacitor simply means you have more than one capacitances in the system, and you turn them or you vary them at the same time. Right. So vary the capacitors at the same time. So let's do a gang capacitor right here. So let's say if you have one here and we have another right? And we have this variable symbol, but then dots connecting both of them. They're variable, right? So ganged. So this is ganged. You might see a circuit where you have them looking like they're connected in series. Then you have the arrow this way. Once you see this link, as you highlighter here. So once you see this linking, it's ganged. Otherwise, it's just variable. You also have a trimmer capacitor. So they just make it like a T. The cross will be a T. So this will be your trimmer. Usually small value, so you connect it either in series or in parallel with other capacitances to trim the value to get you more precise. So if you want to get precise, you want to add a trimmer to your system. Okay. So if I'm going too fast, just pause the video and watch it again, or you can come back. Since we're going live today, you can just come back at another time and watch it. Okay, let's look at other transistors, right? So I said there are different transistors. We've looked at two major ones, but how about MOSFETs? I don't think we've spent time to do MOSFETs, and it is important that we look at MOSFETs because very soon we're going to do inverter, microcontroller based inverters. Again, don't forget that we're going to do 1 kilowatt inverter. We're going to show the circuit diagram for that. So this is coming, and we're going to use a MOSFET for it. So before that, let's just introduce the MOSFET symbols. Okay, MOSFETs are just like transistors, but they are metallic oxide silicon field effect. So this is field effects, and this is transistors. Okay, then this is just metallic oxide silicon. So metallic oxide silicon field effect transistor. All right. So the symbols, there are two major ones we're going to look at. We're going to look at the N channel and the P channel. Okay. So for the let's just draw the generic symbol. Let's treat it like other transistors. Okay. This is the symbol of your MOSFET. Yeah, if you know this before, you will know it's not really accurate yet. But we're gonna make it accurate soon. Okay, so let's just follow. So these are the two symbols. Now we're gonna make one of them N channel. We're gonna make the other one P channel. And just like we did with the regular transistors before, we're going to include arrows. Okay, let's use the arrows. So when you put an arrow, and we're going to put an arrow for both of them, this arrow is going out. So one of them is going in, one of them is going out. All right, one of them is going in, one of them is going out. Now the one that is going in is going to be our N channel. So again, if you this is going to be a little bit different from the transistor. So I'm going to redraw this. I will redraw it a little bit, and then we can follow the symbols. Right? Let's use the same standard as the other transistors. Why don't we redraw it so that this terminal is facing down? I'll tell its name soon. But let's draw it that way. Let's draw it such that this guy is facing down. Okay. If this is the bottom side of your plate, let's draw this one too to look the same way. All right. So one of them, the arrow is going in. I'm sure you know why I'm doing this already. One of them, the arrow is going out. Again, remember the center line, let's just say CL, center line. All right, we already know where we're going to, and in this case this is left hand side and this is the right hand side. Right hand side, left hand side, left hand side, right hand side of the center line. Right, this is the center line. Now you're just going to do what we did before, so let's use a different color and put a stroke on the left hand side, just straight line. Right, anyone that looks like an N, this one here looks like an N, good. This one here is an inverted N. So it's this way, that way, no, inverted N. So, and we go back to primary school and we say bad N. All right. So the one whose arrow is going in is the N channel. Okay, so let's go back and label the MOSFET. So this is our the N channel MOSFET.